RHA is a form of functional similarity. We use it for classification purposes. And the idea behind this particular functional similarity algorithm is to create functional groups of files which share code and features between themselves. RHA as a functional similarity algorithm is implemented in 4 different precision levels. And those 4 different precision levels are just a measurement of how similar are these files one to another, right? The basic precision level, level 1, is stating that the files are 25% similar between the other files in that group. And that is kind of like the largest set of files which you can possibly have. And then we have smaller groups within that, and those smaller groups are at 50% similarity level. So more of the information which is present within the file gets hashed together to create these kinds of groups. And then similarly, we go up to 75% and 100%. And 100% files are completely identical, but there are still minor changes between the files. So only the functional components of the file are identical, and that's kind of the idea. Depending on how do we want to do classification, any one of these precision levels can be used. Typically, we use 50% precision level because it involves not only the code of which the application is referring to, things like functions and so on, but also the actual code itself is part of that hash. And ultimately, that is the safest way to say that the files which are similar are only malicious. And that's how RHA as a functional similarity hash works. Only if the files which are similar to each other are malicious, we use it for classification purposes. So there might not be a single file which is considered to be known good for that bucket to be used for classification purposes. Now, people usually compare or ask about comparisons between RHA and other similar algorithms, and typically those only 2 are mentioned, really. One is used specifically in the security community. It's called imphash, and imphash really stands for import hash of just the import section for the executable file format. RHA is a different kind of algorithm. It uses the imports themselves, but it uses a lot more of the functionality of the file to create that hash. And as opposed to imphash, we do a lot of the pre-processing before we actually compute the hash. So data is normalized, it's sorted, and then ultimately hashed. The reason why that is good is because it enables us to group things which are slightly different into that lowest precision level. And if they are similar at the lowest precision level, then you can, kind of group different types of packers which behave similarly in the similar smaller bucket. And then as you're rising through precision levels, they kind of start differentiating themselves. So that's why RHA can be used to classify things which are similar but not necessarily identical. And if you needed to, you can just go up the levels and classify only things which are identical. It really depends on how we want to apply classification. And that's why it's different from just import hash. The other algorithm people usually ask about is SSDeep. And SSDeep is not an algorithm like RHA. RHA is an algorithm we specifically designed for the file format it's meant to group files in. So there's one implementation for executable files for Windows, there's one implementation for executable files for Linux, one for Mac, and so on. The list grows on, and then we implement them specifically depending on the problem we're trying to solve. SSDeep is universal. SSDeep works on any kind of content, but it's predominantly used for email messages. And the idea is to reduce the number of spam messages an organization receives. And because of the way it's computed, it's a lot more difficult to find if the files are similar or not. It's a higher lookup complexity than RHA. RHA is looked up instantaneously. There's no comparisons between computed RHA and all of the other ones we have. SSDeep does not work like that, and you kind of have to gauge how similar the computed value is to the one you want to blacklist. So a lot different use case than what we're looking at with RHA.